Hi again, welcome to Common Core Algebra 2. Today is 3.6, Piecewise Linear Functions. Functions expressed algebraically can sometimes be more complicated and involve different equations for different portions of their domains. These are known as piecewise functions, and they should not be completely new to you because you should have seen them a little bit in Algebra 1. So I'm going to slide this up a little bit, and we're going to take a look at exercise 1. So, taking a look here, we have f of x. Show you where I'm looking. I'm looking right over here. And we can see how we have x minus 3 between negative 3 and 0, not including 0, right? So, in this case, it includes the negative 3, but it does not include the 0 here. And then 1/2 x plus 4 is including 0 and including 4. So, let's take a look at what that looks like on our table. So as you can see, the negative 1 is kind of the cutoff. So I know that when I put negative 3, so I know this one here is the x minus 3, and I know this one here is 1/2 x plus 4. So when I substitute my negative 3 minus 3 is negative 6, negative 5, negative 4. When I put 0 into the 1/2 x plus 4, I get 4. When I put 1 in there, I get 4.5, and I get 5. And then I get 5.5, and I get 6. So, we have to graph this now. So let's come over to our handy-dandy graph. Making sure I did not unplug my microphone, which I did not. I'm still here. Yay. All right, so negative 3, negative 6. 1, 2, 3, 4, 5, 6 is right here, and it includes that point. And this point, I'm sorry, and so we are at, one more time, negative 3, 1, 2, 3, 4, 5, 6 here, and we are here, and we are here, and this is where it ends. So I'm going to have an open circle here. And then at the next part, we're going to 0 at 4, 1, 2, 3, 4. Remember, this is a function. So if we do our vertical line test, we're going to hit up here at this point we just drew, but we won't hit down at the bottom. So now this one is going to be here, and it's going to be here. Notice how I'm not going to put those 0.5s in. You can if you want to. But that's what our piecewise function f of x looks like. Okay? State the range using interval notation. So the range is kind of, remember, that's the y's. So we're going to go from here, almost to here, and then from here to here. So when we look here, we're starting at negative 6, and we're including negative 6, so square bracket, negative 6 to 3, not including 3. Then it starts again at 4, and it ends at 6. And because we include both of those, we have a square bracket. And we're going to use the or sign between them, because that tells us that it's going to be this one or this one. It's the union of both of those sets. All right, again, union, something you learned in Algebra 1, should not be new to you. All right, so pause, take all this in, write down what you need to, and come join me again for exercise 2. Okay, so we basically took the piecewise function and created a graph. You should also be able to translate the graph back into a function. But this can sometimes be a little difficult to understand because not every function might be viewed the same way. So the way I'm going to view this one is I'm going to view this one where from here to here, I'm going to include those two in that horizontal line, which means that when I take a look at this piece here, from here up to here, when I get to this point with the green, I'm going to have an open circle. And when I get from this point here, this is going to be an open circle, and I'm going to have to come down here and a closed circle. So I kind of have to figure out what my domains are before I can start writing my function. So I know I'm going to have function f of x. So let's do function f of x, and we're going to use that really fun little bracket. And I'm going to start with my domains. So my domain and my x value, so I'm going to start here, which is at negative 8. It includes it, so less than or equal to x, and I'm not going to include the negative 2, so strictly less than negative 2. So x is between negative 8 and negative 2. For my next piece, which is the blue piece, I could have done that in green and really been color-coded here. But the next piece will start at -2. I'm going to include it. And I'm also going to include that +3. And then for the red piece down at the bottom, let's do that one in red. And that's going to go from +3, but it's not included in that red one. X, I just said it's not included in that red one, and the hand wrote something different. So 3 less than X, but that 6 is included. All right, so those are my domains. So now let's consider what the functions look like. So if I consider the green piece, right, if I figure this out, it looks like this green piece has a slope of up 3 over 2, right? Up 3 over 2, up 3 over 2, up 3 over 2. But we need the y-intercept. So even though it's not included, we're going to consider kind of extending that line to find out that the y-intercept is right there at +7. So we just said up 3 over 2x plus 7 for our first one. Now our second one, which was the blue, is simply the line, the horizontal line, at y equals 4. I know it's kind of weird just to put a 4 there, but that's, remember, it's f of x equals 4 from -2 to +3 inclusively. And then the red is going to be, let's see if we can figure this one out. This one, I think, is down 2 over 1. Yep. So that's going to be a slope of -2. But remember, we have to follow it up. Oop, we're running out of graph here. But I think we can use our imagination and see that it could be right up here at +10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be a +10 here. So it's -2x plus 10. Not bad. I think that's easier than doing the first one. That's just my opinion, though. So pause the video, write down what you need to. Again, really helpful to maybe have some graph paper at home that you can tape it into your notes just for that one little graph that you'd be able to use as a reference. Okay? All right, moving on. Exercise 3. Consider the piecewise function shown, g of x. Okay, determine the y-intercept of this function algebraically. And the question is, why can a function only have one y-intercept? Well, you kind of answered it with the word that we said. Okay, why can a function only have one y-intercept? Because we're talking about a horizontal line test, right? So if you're talking about a vertical line, and the vertical line happens to be at the y-axis, if we have two y-intercepts, that contradicts our definition of a function. So you can take a minute and write that down there, but we're going to move on now to determine the y-intercept of this function. So that basically means when g is 0. So when g is 0, we kind of need to take a look at where in the domain g is 0. And g is less than 2 right here. So this one says x is greater than or equal to 2. So we need where 0 falls in. So that's going to be the x minus 5. So we're going to do 5 minus 0. So the y-intercept is going to be at 5, because g of 0 is equal to 5. B says, find the x-intercepts of each of the individual linear equations. Okay, so the x-intercept of each one. So that means it wants us to find when g of x equals 0 for each one of these. So figure 5 minus x is equal to 0, negative x is equal to negative 5, so x is equal to 5. That's for the first one. And the second one, g of x is equal to 0. We have 1/2 x plus 2 equals 0, minus 2 from both sides. 1/2 x is equal to negative 2. So multiply both sides by 2, and x is equal to negative 4. Okay, because you have to really look at the domain, and we haven't really done that, but there's something to be said in D for that. So let's graph this piecewise function. So basically, it tells us we have, the first one is negative x. Let's rewrite that one, because this one says 5 minus x but that kind of gave me the heebie-jeebies. So I want to move this around to negative x plus 5 to have it in that nice y equals mx plus b form. So that means 1, 2, 3, 4, 5. And the domain for this one begins at positive 2, but it's an open circle at positive 2. So it's a negative slope. That means right here I'm going to have an open circle. And it doesn't stop, okay? It just says that it's going to be less than that. So that means from here, from here, from here, from here. And that means from this point we have to put a line and make sure that we put an arrow at the end of that. So our next portion is going to be 1/2 x plus 2. So again, this one would start at 2. We can't really do this. And up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. So here are our points. And because this one actually begins, this one has to be a closed circle. It makes it easier when you have colors like this. So you can see that that point actually belongs to the second function. All right? And D says, why does your graph contradict the answers found in part B? Well, B asked for what the X-intercepts were. And we found the X-intercepts right here for each of these equations to be 5 and negative 4. But as you can see, they do not follow. If you look at 5 right here, this is the first one we did, 5 is not less than 2. So this one is invalid. And when we look at the next one right here, and we have that right here, x is negative 4, well, we have our domain being x is greater than or equal to 2, so this one too is invalid. So that's the reason why it contradicts, the graph contradicts what we figured out, because we weren't really taking a very close look at the domain for each one of those pieces of that function. Hope you got all that. Pause. Write down what you need to. Remember, take those notes because that's what I'm checking tomorrow. You did a great job today. I'm going to be such a happy teacher tomorrow when you all come in and you have watched the video. Don't worry about E. We're going to move on. For the piecewise linear function f of x, find all solutions to the equation where f of x is equal to 1. So we're going to, what that basically tells us, so f of x is equal to 1. Remember, f of x is the same thing as y equals 1. So we have to look at two situations here. 2x plus 10 equals 1, and 5x minus 1 is equal to 1. Minus 10, negative 2x is equal to negative 11. Divide both sides by 2, and x is equal to 11 halves. Now 11 halves is the same thing as 5.5, right? Sometimes it's easier to look at the numbers. So when I take a look at my domain here, my domain is x is less than or equal to 0. So this is the domain. And we can see that 5.5 does not satisfy that. So this is invalid. Take a look at the next one. 5x minus 1, add 1 to both sides, and you get 5x is equal to 2, and x is equal to 2 over 5. And that is equal to 0.4. So if we look, we have x, our domain here, just to remind ourselves, is x is greater than 0. So 0.4 is greater than 0, so this one is valid. So this solution is fine. And if you wrote it out just like that, you can even put here, this one is valid. It is within the domain restriction. Okay, I think that's all we need today. I think that you can try and do the work tomorrow pretty easily in class, working with your groups, and we'll see you then. So have a good one.